Let me zoom it out a little bit. You can see the whole question. That's better. Okay. Question number 1.
So for A, the name is but1ene.
Right. Moving on.
For B, it would be cis but2ene, and C would be trans but2ene.
Right, that is correct.
And D would be 2-methyl prop-1ene.
2-methyl prop-1ene. Perfect. Moving on. Part 2.
Means isomers with the same molecular and structural formula, but different arrangement of atoms in space.
Good. Before I move on, I have a question in mind. When you look at this table in part 1A1, you see that B and C are cis and trans isomers of one another, but we don't see any cis and trans isomerism for A or for D. Why is that so? Separately explain for A and D.
Basically, for A, cis trans isomerism is shown when on the one side of the carbon double bond, two different groups are attached. But in A, we can see that on one side of the carbon double bond, two same groups are attached, which are the two hydrogen atoms. And for D, on one side, two same groups, the hydrogen atoms are attached, and for the other side, two methyl groups are attached. So the groups are the same, but they must be different. That's why it's not shown.
Perfect. Good. Okay, B. Before you start with B1, have you revised this chapter before this study class?
Yeah.
Okay, good. Good. That shows. Well done. Continue.
W is compound but1ene, which would be A, I think.
W is an alkene reacts with HBr to form two possible carbocations. In the first case, it has positive portion on the second carbon, and in the second case, first carbon atom.
Yeah.
And there is CH2, CH3. So you're saying A makes perfect sense.
Yeah, A.
Let's move on. Remember, this C is showing the hint or the tip that works over here for a quick answer is that this C is showing positive. This is the second carbon atom. This C is showing that's the first carbon atom. The rest is CH2, CH3 in both the cases, or this one even show the whole propyl chain to us, which is the only case
Yeah.
with A. If there were two
yes.
CH3s, it might have been this, but that's not how it works. Since there is a CH2, it clarifies it's not D, it's A. B and C were not
Yeah.
given the options, so you might not be falling for that. Okay, so B2.
Yeah. This would be the skeletal formula of the major organic product form, and this is the major organic product because the carbocation formed during its production is a secondary carbocation which is more stable than a primary carbocation, which is found in the minor organic product.
Perfect. Next, C.
It is used as a dehydrating agent. Specific acid.
Right. Next, D.
It's an oxidation reaction.
Good.
Why it reacts formally.
Why are you not calling it a redox reaction? Why just oxidation?
Those alcohols can be oxidized with the K2Cr2O7 and KMNO4. That's why I said oxidation. The first thing that came in mind.
Okay. And that is actually correct. You're supposed to call it oxidation because that's the only thing we're concerned with, what's happening to the organic product. Okay.
Yes.
What happens that to the Tolan reagent itself is none of our concern. Okay, moving on to the part 2 of the same portion.
It contains aldehyde, only aldehyde.
Only aldehyde. Good. Moving on. Next question. Hydrocarbon is too easy. A2.
I don't remember studying this. Sample of naphtha. I think we took this in IGCSE. I don't remember.
Naphtha is.
Is this in?
Okay, go ahead.
Is this in the book like this? Raw materials used to produce these.
Yeah, it is there in the book.
Oh, okay.
It's also a part of hydrocarbons chapter. It's from the same chapter. It's nowhere out of it. And this is something we have studied back in IGCSE as well
we
as
have.
AS in both the classes.
Okay.
It's also a part of the AS book. It's such a common sense based questions that sometimes students think that it might be a difficult, more complicated, or more advanced question. That's actually, it's, to be honest, the most basic one. And let me tell you, naphtha is actually a proper fraction. So That is too big of a hint to answer the question, I believe. Just like
The proper
gasoline or
answer.
petrol or diesel or
So
lubricating
petroleum
oils.
is the raw material.
Yeah, crude oil, petroleum. Well
Yeah,
done.
crude oil. Yeah, yeah.
So you see how basic was the question?
Yeah, it was really
But
easy.
this is a common technique played by Cambridge, that they keep giving you advanced questions so that your mind is used to think about every question in an advanced way. Your mind is used to
Mm-hmm.
think that every upcoming part is complicated. And then they give you a very basic question, which is usually a part of memorization that has nothing to explain out of
Right.
the understanding or knowledge based portions. So, what you do is that since your mind is pretty used to go with complicated calculations and answers, uh, going with some stuff that is layered, layer after layer, you uncover those layers and you answer your questions, and then boom, there is a basic question. And your mind tends to think in the same way, and you overcomplicate the whole situation due to being
Yeah.
used to it. This is a very common tactic that Cambridge plays. And there you go, you have an example right in front of you.
Yeah.
So sometimes when you're stuck, don't presume that the question is from either from too basic portions or too advanced portions. Don't do anything like that. If you're stuck, there is a good way to take a deep breath. आंखें बंद कर लें. Take a deep breath. पेपर के बारे में ना सोचें. Empty your mind for a second or two. Relax. Then get back
Uh-huh.
to the question by like restarting your mind. Another good way to
All right, sir.
restart, and most of the students are not capable of doing it. ज्यादातर स्टूडेंट्स पहली आप प्रैक्टिस में तो ये काम कर भी नहीं सकते हैं. वो आंखें बंद भी कर लें, वो डीप ब्रेथ्स भी ले लें, वो क्वेश्चन के बारे में मुसलसल सोच रहे होते हैं. They can't empty their
जी.
mind because it's easier said than done. हम कह तो देते हैं बड़े
Yeah,
आराम
that's
से
right.
empty your mind, but under pressure mind को empty करना बहुत मुश्किल काम है. It's almost near to impossible. So what we ask our
Yeah.
students, if you're not capable of doing this, don't try to do it again and again. Instead of wasting time, वो question या वो part छोड़ दे, अगले पे चले जाएं. But remember, you need to come back to it. ठीक है, उस पर दोबारा वापस भी
जी,
आना है.
ठीक है.
जिसका मतलब ये है कि पेपर को इन टाइम खत्म करना है ताकि पेपर रीचेक करते हुए इनकम्प्लीट या लेफ्ट ओवर पार्ट्स को आप पूरा कर सकें. ये ना हो कि ये भूल
जी.
जाएं कि हमने कोई लेफ्ट ओवर पार्ट भी छोड़ा है पेपर के एंड पर, आप वो छोड़ा हुआ खाली पेपर ही सबमिट कराएं. That's why recheck is very necessary if you're used to do this.
ठीक है, सर.
Okay, moving on. D.
This is thermal cracking.
Right. Why did you not say catalytic cracking? Why thermal cracking?
I think we can say catalytic too because we're using the Al2O3 catalyst.
Yes, you
I
can't
think
really
both are
say
fine.
catalytic cracking because
Yeah.
there is no mention of catalyst over here. When it happens
Yeah,
like
it's in heat.
this, then your answer should either be just cracking, or you can, since heat is mentioned, you can write thermal cracking. So either write just cracking. Don't go for catalytic cracking even when there is no catalyst mentioned. Since there is heat and you're sure there is heat, then you can write thermal cracking. Either write thermal cracking or just cracking. Do not write catalytic cracking if the catalyst is not mentioned, like in the case it has been mentioned over here. Okay.
Yes, sir.
So this means the point I'm trying to make is that try to go with the flow instead of having a hard and fast rule-based mind. Don't go for hard and fast rules. Don't go for pre-assumptions. जो पढ़ें उसके हिसाब से चले. माइंड बना के नहीं जाना कि मैंने आंसर में हर सूरत अन्य वाक कैटालिटिक क्रैकिंग ये लिख के आना. That's not how it works. ठीक है, क्वेश्चन
Yeah.
आंसर पढ़ें
Yeah.
और फिर आंसर अकॉर्डिंग. Because the examiners tend to keep changing their methods of asking questions every year. So that's why we propose this to our students as a better solution.
All right.
Okay. Part 2.
It's propane. I mean, no, 5-pentane, 5 carbon.
Right, 5-pentane. Okay, moving on. C.
Yeah. Propane.
Easy. Both parts.
Carboxylic. Yeah.
Carboxylic acid, good. C2.
And use aqueous bromine, and it will be decolorized if the
Perfect.
carbon-carbon double bond is present.
Perfect. Okay, moving on to D. And the word at the end of it, which is probably half missing, is repeat unit.
All right, repeat unit of polymer Z. Okay.
The way they have drawn it makes it a little bit tricky.
Yeah.
But if you convert the skeletal into a proper displayed formula, it might come easier to you that way. Skeletons are usually difficult to recognize because they need more practice.
Yeah. So I've converted it into displayed formula. And like, where do I put the double bond?
Where to draw the double bond? Carbon-carbon double bond, is that what you're talking about?
Yeah.
Okay, try and notice something that you have one carbon atom over here, one over here, one over here. And since this one can make the bond and this one can make the bond, and that's why we have continuation over here. If I remove this bond and if I remove this bond, the double bond has to be in between these two. not in between these two. There can't be a double bond in between these two. Because wherever the continuation is attached, if you remove the continuation, those two carbons are supposed to have a double bond in them, since addition polymerization has been mentioned in the question.
Okay.
Okay.
Yeah.
So I hope that clarifies that if I draw it this way, so it would be like this. And of course, we have C double bond O, C O negative, Na positive. Since this whole
And then
thing
just
is quite problematic to understand, so I'm going to erase this whole thing and simply write COONA to simplify it.
yeah.
So of course, there is one hydrogen over here, one and one over here and here. So that clarifies.
All right. So here we just remove the continuations and then add the double bond to the carbon, which was
so they removed this double bond, converted into single, and there we go. We had these continuations, and these are these continuations.
All
right. Okay.
All right.
I hope that explains it.
Yeah.
E.
Oh, goodness. Carbon dioxide for the first part.
Carbon dioxide, right? And for second.
Yeah. Okay. Describe the consequence other than the enhancement of the company's solution. HCl. Gas and acid rain. I think I studied this somewhere.
But HCl is produced when you burn something that consists of halogens. If polymer Z contains halogens, your answer is correct. If it does not, your answer is not correct then.
So it must contain the carbon.
It must contain, yeah, but most polymers based on organic contain carbon. That's not the point. But if I talk about HCl in specific, it has to contain halogens, specifically chlorine.
Okay. All right.
And if we're continuing with the previous part, and this was the repeat unit of polymer Z, so it does not have any chlorine or halogen attached to it.
Which will be producing the combustion of pure Z. Carbon dioxide. Carbon monoxide, then?
Carbon monoxide. Remember, he never wrote complete combustion.
Yeah, that's
though he wrote pure Z. Sometimes students mistake pure Z with complete combustion. So no, that's two entirely different things. Pure Z means we have Z, but it doesn't mean we have excess of oxygen as well. So there can be a little bit carbon monoxide produced along with carbon dioxide, and sometimes even when we have excess of oxygen, sometimes a little amount, a very little amount, trace amount of carbon monoxide is produced with carbon dioxide. But that would only be the first part. What would be the consequence?
Consequence binds to the hemoglobin in your body and prevents it from carrying oxygen, so death.
Right, good. So, number 3.
Electrophilic addition.
Good. B.
The catalyst is H3PO4.
Perfect.
And conditions are 360 degrees Celsius temperature and a high pressure.
Okay. Since they specifically asked to name the catalyst, so how would you name it?
phosphoric B phosphoric acid.
Phosphoric 5 acid. It's not B, it's
Yeah,
5.
phosphoric 5. Yeah, 5.
Phosphoric 5 acid. That is right. Good.
Yeah.
Make sure name and formulate or identify different words have been answered correctly. Right? Moving on to
All right.
C. C is relatively easy. So it may require a little bit of counting, but it is relatively easy. Assalamualaikum Iman Beta. We have only been here for half an hour. We still have half the time to go. We are doing theoretical questions. This is organic chemistry, and the current chapter is hydrocarbons. We are practicing hydrocarbons. And this is the very start of the questions. Probably this is the third or fourth question we are at. Third question. May June 2021, paper 2-1, question 6.
All right. So for C3H6, there's 8 sigma bonds and 1 pi bond.
Perfect.
And for C3H8O, there's 11 sigma bonds only and no pi bonds.
Why? Why no pi bond?
It's an alcohol. All the atoms are, all the bonds are single.
All the bonds are single bonds. Even alcohol can have double bonds. That means we're not handling an alkanol, we're handling with an alkenol probably. But since this is completely made up of single bonds, that's fine. Okay, D1.
I can draw the displayed, right, as well, because they didn't specify which type of structure.
It's totally up to you.
Yeah.
Whether you do raw, displayed, skeletal, since it's not asked in question and as a mandatory part, so it's totally the choice of student. And these open-ended questions are actually better for students, but they never give completely open-ended questions in the paper. So they try to bifurcate it. If there's some question that is open-ended for the student to choose whether to draw the displayed formula or the skeletal, there are some questions which are bound with one specific type of structure.
All right, sir.
Let's leave the edges. Just draw the bonds.
Yeah, let's leave it. Yeah.
The edges. Even if you don't draw the bonds, I'll get the idea. So let's move on.
A minute, I'll draw for the less stable one.
You're leaving edges for now, just because of the time. I suppose you understand that you are going to draw all the edges in the exam, or whichever way you prefer it with.
Yes. Here. In the first part, I drew one extra carbon.
Right.
carbon atom. Yeah,
I
yeah, by
was
mistake. I just
about
noticed.
to talk about it. So which
Yeah,
one's
yeah.
extra? Let's be a little bit more
Uh,
specific because
we can
removing any of the
exclude
carbons would probably change the way you are about to draw it. So remove the one or erase the one that you think you've drawn extra.
this one.
Okay, understandable. That's correct. Why is the one less stable? Less stable.
Because it's a because it's a primary carboketine,
Mm-hmm.
and primary carbocations are less stable,
Mm-hmm.
and the more stable carboketine is a secondary carboketine, and secondary carbocations are more stable than the primary ones.
Understandable, but this would only get you 2 marks, not the third one. The third one requires a more deeper explanation. So pick any one of these, either more stable or less stable, and tell why it's
About the
more
alkyl
stable.
groups, the electron donating effect of the
Be more specific.
so the more stable carboketine
Mm-hmm.
contains two alkyl groups,
Good,
which two alkyl groups, so the positive inductive effect is greater.
good. Now the explanation is complete. Remember, they have given you 3 marks in 3 lines, which means it required a more explanatory handling for the question. Okay, part two.
All right. Naming. Okay, just a minute. CH3, CH4, propan 2 all.
Up and two, good. Moving on. E1.
2 bromopropane, hydrogen, nitrogen, hydrogen, correct. This is a elimination reaction,
Elimination reaction. Moving on.
and the reagent is ethanolic sodium hydroxide, and the condition is heat.
A condition should also contain ethanol because the reagent itself is just sodium hydroxide. Ethanolic is actually the
Uh-huh.
condition because we don't want water to be a part of the reaction.
Yeah, yeah.
Reactants.
Okay.
Right? Put
All right.
it differently. Okay, number 4. One of my favorite kind of questions.
Yeah, it's pretty
The
hard.
big mind maps usually try to scare the students way too much to properly think about the questions. जब एक
Yeah,
पूरा सफा
that's
भरा
the
होता है
thing.
शुरू से एंड तक केमिस्ट्री
Mm,
कंपाउंड से तो एक दफा तो बच्चा वैसे ही देख के घबरा जाता है ना. So the capability of answering the questions right is gone. It goes down the drain.
सही बात
Let's
है.
start with A. So even when you cannot see the whole table, I hope the dotted lines gives you the idea that for 1 and 6, we need the name of reaction
Yeah,
mechanism.
name and condition.
And for in case of 2, we though we don't need the name of the mechanism, but we require the rest, regions and conditions.
All right.
So the only exclusion is name of reaction mechanism for reaction 2.
Okay, so the first reaction, the name would be electrophilic addition,
Good.
and the reagent would be steam, and the conditions would be uh H H3PO4 H3PO4 and 360 degrees Celsius and high pressure.
Good. Good. Moving on. 2. In which we only require regions and conditions. We don't require the reaction mechanism.
The name, okay, only the reagents and conditions. Okay. So we use acidified K2Cr2O7 and
Right.
you heat it under distillation.
Hmm.
The aldehyde is formed.
It's better to say warm than to simply say heat, because heat gives you
So,
the idea it can be strong or it can be light. So warming means we go with less heat, not too much.
so warm under distillation.
Yes, instead of
All right.
heating, you try using the word warm wherever it is applicable in the part of
Okay.
organic chemistry. Okay, I understand you don't know the mechanism. We haven't even taught you, that wasn't a part of the book.
Mm-hmm.
But if I ask you the kind of reaction it is, what would your answer be? What kind of reaction is reaction two?
We're oxidizing basically a primary alcohol into an aldehyde.
Oxidation. Very good.
Yeah.
Very good. Moving on to six.
I need to tell the name.
Yes, in this case, you need to tell the name of the mechanism as well as the reagents, name of the reagents, and name the conditions.
Okay, so the name would be nucleophilic substitution,
Good.
and conditions would be ammonia. The name of the reagent would be ammonia,
Mm-hmm.
and conditions would be a a high temperature and a high pressure.
High temperature and high pressure. Good. Good. And keep in mind that we specify that ammonia is dry, or writing alcoholic ammonia is a good way to do it. Remember, it's not aqueous
Oh
ammonia,
yeah, it's ethanolic. Yeah, yeah, ethanolic ammonia.
ethanolic ammonia.
Yeah, yeah, I
Okay?
remember. Mhm. Yeah,
This has to be specifically ethanolic ammonia. Now, why did you call reaction 6 a nucleophilic substitution?
nucleophilic substitution
You're
because
correct. One, you're correct.
yeah, yeah,
But explain to me why.
nucleophile is chlorine there. Okay, why the nucleophilic substitution?
So, since you're thinking loud, I need to come up with another question. You're right. The first nucleophile, which is already attached over there, is chlorine. We
Replaced, yeah, by
substituted with
the
another nucleophile, which in this case is
yeah,
ammonia. How come ammonia is a nucleophile? Why do you call
because
ammonia
the
as a
central
nucleophile?
atom nitrogen has a lone pair.
Lone pair. Good, good, well done. Okay, moving on to the next part, B1. We won't need to go back to the mind map because whichever molecules are reacting
Yeah.
have been properly given over here in the diagram, so you won't need to consult the previous mind map.
Okay, so I'll do the mechanism. This is delta positive, delta negative on oxygen, lone pair. I can add a lone pair, right, to the cyanide here.
Sorry, I was talking under mute. Yes, you can and you should. Good.
All right, so this attacks this, and then this bond breaks like this. And then this is delta positive, positive. Cyanide is delta negative.
Right. Makes sense.
Then this lone pair will add a lone pair here. This attacks the electrophile here. And then this bond breaks like this, and cyanide is regenerated again.
Right.
This would be the
That's good.
mechanism.
I understand you are currently annotating on the computer, but
On a touchpad, yeah. That's why it's a bit hard.
yes, it's a bit hard, but I just want to make sure that you're doing it correctly. So let me clarify
Yeah.
that when we draw the arrow, and if it has both the sides of his face, the arrowhead,
Mm-hmm.
which we call, this means that the entire bond shifted from one point to another, and of course, it turns it with a negatively charged species, like in this case, sorry, my bad, this case or this case, right? If
Mm-hmm.
you draw it just one-sided, it is then a fishhook arrow, and this usually talks about the
The
uh,
homolytic,
homolytic fission and
homolytic
only one
fission. Yeah.
electron moving at a time, not the entire bond. So make sure, and you can't justify your action with the simple phrase that, yeah, I was in a hurry. Everybody's in a hurry in a paper. So the arrows should be very well drawn,
Yeah, right.
because if they
All right.
have a doubt about the arrow that it is not drawn the way it is required to be, they cut a mark for it. And we,
All right.
besides all our hurry, keep thinking after the paper that we have done it right. Actually, we haven't. So let's be
Mm.
very clear about drawing the arrows, since they have separate marks, and these 3 marks do have the marks included for those arrows. Let's make sure that we
Mm-hmm.
draw them correctly every time. Okay, part 2.
All right. An alcohol functional group and a nitrile.
Good. And
Not
if you
structure
have
programming.
to If you have
Yes,
to clarify to me what kind of alcohol group is that, primary, secondary, or tertiary, how would you clarify it?
it's a secondary alcohol because only one hydrogen atom is attached to it.
One hydrogen atom is attached to the carbon, the alcohol is
To the
attached to,
carbon
right?
bonded to the,
Right,
yeah,
right.
alcohol group.
It's better to discuss it on the basis of alkyl chains on that carbon, or the carbons attached to those carbon atoms. But yeah, that's fine. You can talk in reverse argument on the basis
Yeah, I
of
did it with
hydrogen atom as
hydrogen.
well.
Yeah.
That's fine. Okay, moving on. C.
Can I see reaction 4?
Yeah, sure. In fact, I need to see the reaction form by myself.
Okay, so my trial and heating with dilute acid. So, okay. So one would be, I think, acidic hydrolysis of the
Okay.
nitrile.
Okay, and that results in. I think I should keep on the same page and you can draw it over here. That's fine.
Yeah. So it will give the carboxylic acid. Acidic hydrolysis. Three carbon atoms. Three electron.
H on the
Um,
other side. Try to make a habit out of it.
oh, okay. Yeah, one, okay. 1, and then CH3 like this.
Yeah, you may write CH3, you may. Since you're drawing everything, yeah, you need to write CH3. Good.
Yeah, I think that would be it.
No, that's not it.
No? Carboxylic acid plus this. What am I missing?
You converted a nitrile into a carboxylic acid, and there is the alcohol that was previously present as a part of the structure. And if you haven't converted a nitrile into a carboxylic acid, you might have converted it into a ketone, which is not right.
We have to add the OH group as well. Where do I add it then? I mean, there's 4 bonds of carbon.
Yeah, actually, there are. Wait a second. Okay, this is this carbon atom. This carbon has
Yeah.
one CH3, and then there is a carbon over here too, which instead of this is going to form COOH. So it's not this carbon which is going to form this, or if this carbon has, actually you can't really do it over here, so it has to be COOH over here.
Oh, okay. Okay. I think I get it. Okay.
Now this should make more sense. Okay,
It makes sense, yeah.
I advise the students about the skeletal structures that if they get confusing, just make the changes wherever they're required and try to draw it in the same way. So it's OH over here, and it's CH3 over here, and this C triple bond N, which has been drawn like this, and there was no C in the diagram, so just simply cut this one out and write COOH over here. This should make
And then we just complete the structure.
Okay,
yeah,
but since it was skeletal, if you need to draw it like this in a proper skeletal way, it should be something like this: O, OH, and OH.
All right.
I hope this makes sense. This would be the exact skeletal structure. Okay, let's erase it. Move on. Actually, this finishes up the question. Let's start with question number 5. Yeah, A1. Let's start with A1. It's fine. Though 1 and 2 parts are easy, but let's go with this since it's a part of this chapter and can be asked as a question. Let's not skip these.
Tracking.
Right. Moving on.
Low MR are more suitable for use as well. They're more reactive.
Sorry.
They're more reactive.
No, that's not it. Just because something is more reactive, we don't use it as a fuel. Then why aren't we using the most reactive of alkali metals as fuel? We don't use them as fuel.
Because they release more energy.
Release a higher amount of energy. Right,
yeah.
right. You may say that they burn easily, which comes as a perfectly good reason for being a fuel, but you can't really say that they are more reactive as a reason for being a fuel. Okay. 3.
Yes. Equation. So C4H8 plus 4O2 reacts to give 4 CO plus 4H2O.
C4H8, you just said, reacts with how many oxygen molecules?
4 moles of oxygen,
Uh-huh.
and it gives 4 moles of carbon monoxide and 4 moles of water.
Makes sense. Next.
We can use infrared spectroscopy, and how this may be used.
A little out of the
Uh,
chapter, but hope it makes sense.
yeah, we can use infrared spectroscopy, and it will be used by measuring the amount of radiation which is absorbed
Actually, you
from
need to
the.
compare it, or you go with the fingerprinting system, compare it with the wavelengths or wave numbers.
Oh, okay. So compare the wavelengths.
Right.
Oh, yeah, and then
Compare with
match
the
it with the
wavelengths,
carbon
or
triple
we
bond. All
also
right.
have been calling it fingerprinting, comparing it with the data. This whole makes
All
sense.
right.
Any
All right.
arguments to that understanding of words would be fine. P1.
Mm-hmm. Complete combustion of C4.
Just tell me the products. I understand that
Yeah,
you would easily be able to balance
one
it.
carbon dioxide and sulfur dioxide as well, and water.
Good. Moving on. Next. Without the change of combustion, leave it. Let's start with number 3.
All right.
Sounds more challenging. But this is related to physical chemistry.
Yeah, that's the thing.
Let's skip it.
Yeah, sure.
Since we have done questions like these, I'm pretty sure you'll be able to do it. Yeah.
Yeah.
6A1. Get 6A1. Directly move to 6A2. That's too easy.
Okay. For part two, identify of methyl protein and butane. So chain isomerism.
Chain isomerism. Good. Moving on. Too easy. Out of course. Telling the sources is going to be extremely easy. You're familiar with graphing. Products won't be a problem for you since the names have already been given these moles. D2. Let's start with D2.
D2.
I'm trying to stick with more challenging questions, or the questions that are at least not a repetition.
Uh-huh. All right. So the bond break, it would be homolytic fission, and the bond would break homolytically, and
Right.
each chlorine atom will take one electron along with it to form a free radical.
Good. 3.
So this is propagation
Good.
propagation
4.
reaction. Yeah. So 4, there would be a CH2 free radical, and the dot would be on carbon, and HCl would be formed along with it.
The radical is not
CH3, I
correct.
mean. Yeah,
Okay,
CH3.
CH3, that's
Yeah.
right.
Yeah,
Okay,
yeah.
moving on 5.
Carbon, I think. Alkanes only contain sigma bonds,
Mm-hmm.
and these sigma bonds require a lot of energy to break,
Uh-huh.
whereas alkenes contain pi bonds, which are reactive, and
Reactive in terms
so
of react with what? As per the question.
they can react with electrophiles,
Right, they can react with
the pi bonds.
electrophiles. Good. Moving on.
Um, Bromine water is decolorized for the first part.
Good. Next.
Yeah, just take me a moment, I'll try.
Yeah, sure, take your time.
This would be for X.
Good. Moving on.
Yes. This would be for Y,
Right.
and Z, only one product. So it shows that Z is a symmetrical alkene, right?
Right.
Symmetrical alkene. So I won't draw it, but I'll say it verbally. So on one side of the carbon-carbon double bond will be one hydrogen atom and one methyl, and the same would be for the other side.
Good. Butene.
Yeah,
But
butene, exactly.
there is a faster way of doing it. You're imagining every product properly. That's good. I don't say it's not right. It still is right, but a little bit slow. Okay, when you're converting them back to alkenes, the process is really simple. CO2 is converted into CH2.
CH2,
Of course,
yes.
since we are removing oxygen, there is a double bond with C. In case of ketone, the whole ketone remains the same when we remove the oxygen at the double bond. In case of
Yeah, two alkyl
aldehyde,
groups.
the whole aldehyde remains the same when you remove the CHOs at the double bond. Finally, when we are talking about the carboxylic acid, in carboxylic acid, when you remove the CO2H, the O2s, you add a double bond. That's how simple it is.
So we're removing.
And you're supposed
okay.
to connect the doubling bonding portions together.
All right.
So this would become CH3, C, remove O2H double bond, and of course the other side would be CHCH3. So there you have your structure. That's how quick we can connect it. CH3, CH2, CO2H. Don't write O2, just CH double bond, and this should be CH2, and the double bond is already there. So if you know these four rules, it's going to be pretty easy. Faster, actually.
Yeah. Yeah, that's true.
Okay. Moving on. Shouldn't have raised those. So molecular formula of X, Y, and Z.
Molecular formula of X, Y, and Z. 1, 2, 3, C3, C3. No, 1, 2, 3, 4. C4, H8.
Right. All of them are C4H8s.
H8.
They are actually isomeric to one another. Be it structural or stereo, but they are definitely isomeric to one another. Part B.
Yes.
I hope you have time to finish the question. Do you?
Yeah.
Okay. Continue. Part B.
B would be primary alcohol, and W would be tertiary alcohol.
Good. Part 2.
Write an equation. Okay. So we'll just replace the H in OH with Na, right?
Right. And it would give you the organic product. Apart from organic product, what are you going to get?
Hydrogen.
Hydrogen, right.
From hydrogen.
Which brings us to the last part, 3.
Reagent to distinguish between primary alcohol and tertiary alcohol. Primary and tertiary. Can we do the oxidation one? Like primary alcohols can
you're
be
on the
oxidized.
option actually.
Yeah, so we can use acidified KMNO4, and for B, it will be decolorized from purple to colorless, and observation W would be the purple color remains of the KMNO4.
You've used which reagent?
Acidified KMNO4.
Okay, your book tells you used the dichromate one, acidified dichromate 6. If you use that, what would be the color changes then?
So for B, it would be orange to green, and W, it will remain orange.
Right, good. Make sure, since this is a very specific test, and we're not going to switch the oxidizing agent in this one, so let's stick to dichromate. Just like in the
KMNO4 is only used in alkenes, basically.
Alkenes, right. In the case of oxidation of alkenes, we use KMNO4. Let's stick to the specific oxidizing agent we've studied in the book. Right?
All right, sure. Yeah.
I think that's enough for today, right?
Yeah, it is.